My dear students, I am Koushik Bera, Assistant Professor of Civil Engineering Department in HIT. Today I am going to lecture on the topic shear strength of soil. So basically, shear strength is generally we know that the shear failure of a soil is a very big important thing. So shear failure in soil generally in different way. There are general shear failure, local shear failure, and punching shear failure. So this is the shear failure diagram. You can see that this is a strip footing, and this is in this strip footing uh, due to the load, soil is failure due to the shear strength. This is the embankment, soil is failure due to the load, mobilized shear resistance. This is the failure surface, and this is the rotation. In this portion will cut due to the failure of shear. So at failure, shear stress along the failure surface reaches the shear strength. Basically, the shear strength, we can say that the resistance of a soil under the loading. How much maximum capacity of how much strain can resist of any soil uh, due under the loading. It may be the dynamic loading, or it may be the static loading. So this is also a shear failure diagram. We can see that the soil grains slide over each other along the failure surface. This is the surface. If we saw that this is a shear strain, the shear strain will occur like this, tangentially. Okay, shear strain will occur tangentially. So this is the failure surface. We can see that this is the failure surface. So soil grains automatically at the shear failure, soil grains moves each other. So no crushing of individual grain. There is no crushing of individual grain. Basically, this is the soil grains is sliding over each other like this way. So at the shear failure zone, we can say this is the tangentially occurred the tau shear strength and the normal stress direction this way. Okay. So at failure shear stress along the failure surface, tau reaches the shear strength tau f. Tau f means shear failure. So we know in the shear strength, this is a very important thing, more Coulomb failure criteria. In this criteria, it's denoted the shear failure envelope, and also we can know the shear parameter also. What are the shear parameters? Shear parameters are basically the cohesion and the phi, angle of shearing resistance, or you can say the frictional angle. So cohesion is C and phi is frictional angle. So here we can see that the more Coulomb failure criteria, we know this is the diagram of tau sigma, this is the normal stress, and this is the diagram y axis, this is the tau. So we can say that the tau f equals to C plus sigma tan phi. C is cohesion, sigma is normal stress, and tan phi, phi is a frictional angle. So tau f is the maximum shear strain of soil can take without failure under the normal stress of sigma. So more Coulomb criteria consist of two components, as I said, the cohesive and frictional. So cohesive is denoted by the C and the frictional is denoted by the sigma tan phi. Sigma f tan phi. Sigma f denoted the failure time, the normal stress. So here this is the tau. Tau means the shear strength along the y-axis, and the sigma is x-axis. So we can see that the tau is basically the failure time shear strength, and sigma is at the failure time normal stress. Here this is the C and this angle is phi, and this component, cohesive component is C and frictional component is sigma tan phi. So C and phi are measure of shear strengths. Higher value, highest shear strengths. We know that the C changes the getting the higher value, so it will give the highest shear strength. And if phi giving the higher value, that means the 30, 38, 38, 39. So it will give the shear strength high. So more circle and failure envelope. So here this is the, we can say this is the embankment. We can say that in in this embankment, this is a failure line. This is due to the failure line, it may be caused some under the loading, or you can say the landslide or something. You can say this is the failure envelope. So in this failure envelope, we took a small strip of soil, and here this is the soil strip which is unaffected. Okay, so in this small strip of soil, we denoted X, and this is the unaffected soil strip is denoted by the Y. This is the green size. So we can, if we draw the failure at the location at the Mohr circle, we can say that this is the X-axis and this is the failure envelope, which we can signify that the Y is safe side. Okay, so Y is stable condition and this is the safe side. There is no effect of a failure envelope touches the Y section. Okay, so now in this Y section, if we make a Mohr circle, if we draw a Mohr circle in this Y section which is unaffected, here some loading in this embankment is applied. This is the diagram. The loading is applied, and in this loading, the sigma del sigma. This is the due to the loading. This is the additional stress, additional normal stress. We can say that this is the deviated stress. We can say sigma c is a vertical or sigma c is a horizontal stress. And in this case, soil element does not fail if the Mohr circle is contained within the envelope. So if we draw, this is the sigma c and sigma c plus del sigma. So del sigma due to the increment. So Mohr circle does not touch. This is the envelope of a Y section. So if the loading increases, that means the Mohr circle will also changes. So at first in this is the Mohr circle I do draw. Due to the loading changes, so delta sigma will be changed. So here the Mohr circle repeatedly increase, and finally it touches the Mohr circle failure envelope. So finally failure occur when the Mohr circle touches the envelope. As loading progress, the Mohr circle will become the larger. Like see this way. At initially this is the circle is lower and it is increasing due to the loading increment. So Mohr circle failure plane is oriented as 45 degree plus 5 by 2. Like this way, Mohr circle will fail. Okay, in this case, Mohr circle will fail. So in this region, so due to the horizontal, it will angle 45 degree plus 5 by 2. So Mohr circle in terms of sigma and sigma dash, you can say that the sigma is a total normal stress, and we can say total stress, and sigma dash is a effective stress. So total stress, we can say that the total stress equal to effective stress plus pore water pressure. So here the total stress we denoted sigma V vertically, sigma H is horizontally, and total stress denoted effective stress denoted vertical stress sigma dash V, and horizontal stress is sigma dash H, and the pore water is denoted U. So this is the effective stress envelope and this is the total stress envelope, and the failure envelope does not touches the both. So this is the triaxial test apparatus. So how can we find out the shear stress due to doing some or conducting some test, like as the triaxial test, unconfined compression test, vane shear test, direct shear test. There are different terms and different conditions. So due to this, we can organize this test. Triaxial test is the most efficient test, and we can do the different type of different drainage condition. We can conduct this test triaxial apparatus. This is the triaxial apparatus. This is the triaxial apparatus mold. We can say that this is a piston which apply the deviated stress. This is the O-ring. This is the impervious membrane, and this is the porous stone is upper side and lower side also. and this is a pipe connecting pore water pressure volume changes. This is a pedestal, and this is a cell pressure where the cell pressure is affected, and this is a back pressure, and the Partex cell. This is the Partex cell we know. So in this Partex cell, the water will fill with this, and also the pressure is connected. Okay, so this is the, and failure envelope is like this way, 45 degree plus pi by 2. This way, to the horizontal, the failure plane will occur. So types of triaxial. Triaxial test also has different type of triaxial. Three types of triaxial. Okay. So this is the under the all around the cell pressure, and this is the loading type. Deviator stress loading type. So if drainage valve is open, remember these things. If drainage valve is open, then yes, this is the consolidated. If drainage valve does not open, this is the unconsolidated sample. If the drainage valve open for loading, this is the drain loading. If no, this is the undrained loading. Okay. So we can say that depending on whether drainage is allowed or not, initially isotropic cell pressure applicable and shearing, there are three specially type triaxial tests. We have practical significance. Consolidated drain, this is the CD. Consolidated undrained, this is the CU, and consolidated unconsolidated undrained U. Okay, generally we do the U test and different types of condition if we want to do. So three tests already we can perform. Consolidated drain CD, consolidated undrained CU, and consolidated undrained UU test. So unconsolidated undrained test in terms of total stress phi u equals to 0. So granular soils have no cohesion C, that means the 0, and C dash is equal to 0. For normally consolidated clay, C dash equals to 0 and C equals to 0. This is the gentle reminder, we can say that. And CD, CU and UU, this is the triaxial test. We can say that the consolidated drain, no excess pore pressure throughout the test. Pore pressure means individual grain, there is some voids. So this void is filled with the water. So we can say this is the, due to this water in the void space, this is called pore water pressure. So no excess pore water throughout the stress, very slow shearing to the avoid build of the pore pressure can be days not desirable, and give C dash and phi dash. So use C dash and phi dash for analysis fully drained situation, long term stability and very slow loading. So this is the types of consolidated drain. Consolidated undrained, the pore pressure developed during the shear and gives C dash phi dash and faster than CD. Preferred way to find the C dash phi dash. This is the another type, consolidated undrained test. And the final type of a triaxial test, unconsolidated undrained. So here pore pressure develops during the shear. That means the not measured and sigma dash unknown, and pore pressure develops during the shear equals to 0. That means the failure develop is horizontal. Analysis in terms of sigma gives you CU and phi u, and very quick test. It is a very quick test comparison to the other test. Use CU and phi u for analyzing the undrained situation, short-term stability and quick win. We generally prefer the unconsolidated undrained test in the laboratory. So thanking you. We will do the next session after this lecture.